All right, to find the mean of these numbers, I'm going to take all 5 of them. So we got 18, 18, 12, 47, and 10. We do not need these in order from least to greatest to find the mean. So I'm just going to add them together. You could use a calculator, by the way. But when I do that, I got 105. Now, once we have the sum of the values, then we can simply take it and divide it by how many values there are. 1, 2, 3, 4, 5. Well, 5 now, 4. And in my calculator, I do 105 divided by 5, and I get 21. That's my mean. That's as much as I need to do. Now, with the mean right there, what they're going to do on the assignment is they're going to give you 2 sets of numbers. You got to find the mean for both, and then you just have to say which one's bigger or smaller, and just compare them together. For the objective today, I can interpret and compare dot plots. That's a little bit new for us. Box plots and histograms. And also we need to be able to determine the skew of data on these types of graphs and plots. Now, while dot plots are new for us, it's actually just a different way to show histograms, which we will see. So we want the range of this data set. And the nice thing about the range, which we do want, so we'll find the range by taking the biggest number and minus or subtract the smallest number. So in this list, I should be able to find that biggest number. And for me, I don't need to put these in order from least to greatest. You're welcome to do that if you'd like. But I can just see, just comparing these, I have a 1 in the hundreds and a 6 in the tens, which is bigger than the 1 in the hundreds and the 2 in the tens. So my biggest number in this list is 166. Then it says the minus, so we get a minus. The smallest number, or the minimum, which for me it looks like it is going to be 23. That's my smallest number, 166 minus 23. This is just something you need to put in the calculator, and we should get 143. So this would be the range. So just like the bell work, once you find a mean, in this case a range, what they're going to do is they're going to give you a whole different set of values on the side, and they'll say find the range for both, and then you got to compare the ranges. The range in a set of data just tells you, another way to say it is the spread. So last time when we saw some kind of box plot like this, right, and this isn't great, but it's doable, is what you have is over here you got the minimum, and then furthest to the right over here you got a maximum. So the range just tells you how far apart these are, and we don't really care about the values in between. It just tells you how far apart they are. It doesn't tell you how many values there are in between. It doesn't tell you where the median is. It doesn't tell you where the mean is. It just tells you how far apart the minimum and maximum are. So yeah, you'll have to compare those. Okay, so data sets. We've seen box plots already, which is kind of what I showed there on the last slide. So of course they're going to have some kind of box like this. Maybe in between they're going to have a median, and then they're going to have whiskers coming out something like this. And just like we've seen before, the line furthest to the left would be the minimum. The line furthest to the right is a maximum. The line right in the middle is the median. And then the outer ends of the box, the left end of the box right here in purple, that was what we called quartile 1. And then the right end of the box we called quartile 3. And from this, from the box part, which we will see today, just a little bit at least, we end up with, it's black, the box part, right? So from quartile 1 to quartile 3 is what we call an interquartile range, which we will see on today's classwork as IQR, interquartile range. So the interquartile range, again, it just is the span between your quartile 1 and quartile 3. Now, interquartile range today, since we're just getting used to this, we can actually just compare the range, but it may be helpful to see the interquartile range because, I don't know, they may throw you a curveball on the assignment. Okay, so that's with box plots. Box plots, we find the interquartile range pretty quick. For a histogram, though, we would not need to find the interquartile range, but it is important for us to see that the x-axis, usually it's going to be some kind of intervals on this. But the truth is, you may not see these in intervals. So today, the bars are still going to be pushed together, but they're not going to be in intervals anymore. And then the y-axis just tells us how many of those values occurred. Now a dot plot, which is new for us down here, this is just a different type of histogram. But instead of using some kind of frequency with a y-axis over here, they're just giving us dots as the bars. So technically speaking, we could make this, I don't know, something like this. So you could say, hey, there's one bar right there. Well, something like this. And then the next one would be too high. See that right there? And then too high. I know my bars aren't great, but something like this. Okay, so if you were to make bars out of the dots, you would have a histogram. And I tried to push those together. But you can even see it's possible to get 0. So without the boxes, which is fine, you can see that that's one dot, which means that whatever this is, 3 occurred one time. Or this one right here, 4 occurred 2 times. 5 occurs 2 times. 6 happens twice. There are no 7s or 8s, but there would be 3 9s and then no 10s. Okay, so again, you could make bars, but instead of bars, we're going to be using dots instead. And the nice thing about that is all you get to do is count. So for those of you that are struggling with this, I don't know, maybe you need to watch more Sesame Street. But just count them, that's it. We'll see some dot plot examples, but again, the idea is really that it's just a different way to show a histogram. That's it. So for this one, we got this box plot down below. Now, in the last lesson, what they did is they gave us values, and then we found the 5-point summary. But here, they're saying, well, here's a box plot, now tell us what the 5-point summary is. So just like we've seen in the past, the minimum is just the line furthest to the left. Now, the problem with this number line right here is that it is not showing how much each of the lines is worth. But it says it has to be the same amount for each line. So we got to look at the scale down here at the bottom. And I can see that 1, 2, 3, 4, 5 marks is 25. So if I want to find out how much every mark is, I take 25 divided by 5. And that will tell me that each mark is 5. So I can put a 5, another 5 is 10, another 5 is 15, another 5 is 20, and we see it matches there. Now I'm not going to list all of them because that's more writing than I want to do. But what I can see is that the minimum just kind of flows down here to 20. So the minimum of this set of data is going to be 20. Now, that wasn't a lot of math, but you do have to do maybe some division if you need it. Some of you would just know, well, I see that everyone is by 5, and that's fine too. So we're going to do the same thing for the next value. I'm just going to go from left to right here because, again, I don't actually have to solve for these. I just need to look and see what the values are. So I'm going to go to quartile 1, which would be this line. That's my quartile 1 on the box plot right there. Now, if I follow this line down, I end up with another value that isn't being shown, but I know every line is 5. So from 25, I'd count up by 5. So that'd be 30, 35. So that mark right there is 35, meaning that my quartile 1, or Q1, is at 35. Now, we don't have to label this, either any of these, because we don't know what this is representing. It's just 35 of something. Next up, we'll go to the median, which is the middle line right here. Now, this one just shows that it's automatically 50. I don't have to do any counting by 5s for this. I just see that the median is 50. Next up, quartile 3, which is the right end of the box. I'll follow this down. And again, this is not being marked for me. So that means I have to count from 50 by 5s. 55 and then 60. So that marking right there is at 60. And my quartile 3 is also at 60. And then the final marking here on the far right, which is our maximum. Again, I can follow this down to this marking, which is not shown the value. You can count from 60, you can count down from 75, 60, 65, 70, 75 down to 70. You should get 70 either way. And so our maximum is 70. That's it. So from a box plot like we just showed right there, we should be able to find the 5-point summary, which we did. Minimum, quartile 1, median, quartile 3, and finally at the end there, our maximum. You will want to keep in mind, we were counting by 5s on our number line here at the bottom, but as it turns out, they won't always be by 5s, so just be aware of that. Sometimes they'll go by 3s, sometimes by 2s, I don't know. Sometimes even by 1s. I can't tell you for sure, but you'll have to find out on the assignment. All right, now we're looking at this graph, and it represents data that was collected by students on a number of social media posts they made in a day. And I think some of you guys make more than these in one day. But this is all we have for the information that's given. Now they've got 2 questions for us to answer. They're not asking for a 5-point summary because it's not a box plot. This is a histogram. So again, you could look at these like we will be doing with dot plots, but the histogram will do fine because we have the frequency as often as it happens here on the left. So let's interpret it. Even if they weren't showing us this information up here, we should be able to interpret it because of the labels on the graph. So for example, the x-axis is the number of social media posts made by a student. And then the y-axis is how often or how many students did that. So for example, if I were to look at this bar right here, that's 5. So 5 social media posts, and here at the top, that is 5. So that's for 5 students made 5 social media posts. Or if I were to look at this one right here, this one is 2 students made 4 social media posts in the day. So we can interpret this. What it's asking first, though, is how many students were surveyed. So we just got to go to the top of each bar and figure out how many students made this many number of social media posts. We don't really care how many social media posts were made right now. We're just asking how many students were surveyed. So overall, for 0, number of social media posts, I can see it just corresponds directly there with the 3. So I know 3 students made no social media posts. The next one, this is 1 social media post, and it aligns with the 1 right there. It's not even showing the line, but we can follow it over there if we need to. So it looks like 1 student made 1 social media post. It's the same height for the next one. So 1 student made 2 social media posts, and 1 student made 3 social media posts. Now I'm gonna figure out what they all are before I add them, but some students like to keep this in the calculator, just have a running total as they go. And that's up to you if you want to do that. The next bar for 4 social media posts, it appears, just following this over, 2 students made 4 social media posts. Now over to 5, which we've already done, but I'm still going to do it again. So again, I'm just going to follow the top of that line over here to 5. 5 students made 5 social media posts. And then for 6 social media posts, again, I just follow this line over, and it is aligned with the 3. So 3 students made 6 social media posts. And now for 7, again, I just follow this line over. 2 students made 7 social media posts. So 2 students made 8 social media posts. So what I want, though, is how many students were surveyed. So again, whether you do it this way or not is completely up to you. But I'm just going to add these together. So I'll start from the left. 3, 1, 1, 1. That's 6. Plus 2 is 8. Plus 5 is 13. Plus 3 is 16. Plus 2 is 18. Plus 2 is 20. We're adding these all together. So from what I can tell, there were 20 students in this survey. So 20 students in the survey. Since I'm doing this by hand, I am labeling it, although I believe on the assignment you do not have to put the label. But there were 20 students that were surveyed total in this survey. So how many students make 6 social media posts? Well, 6 social media posts is this bar right here, so I just followed up. That's 6 social media posts. 3. Now again, it's not just 3, since it's a word problem. I'm going to label it as 3 students. 3 students made 6 social media posts. Bam. Now keep in mind, that's just these 2 questions. On the assignment, what they may do is they may say, well, how many students made 2, through 7 social media posts. Then you just have to add these specific bars instead of adding all of them together, perhaps. Or maybe they'd say how many students made 8 social media posts, 2. Something like that, okay? So just expect maybe something a little bit different on the assignment, but it still corresponds to these values that we just found. The dot plot below represents how long it takes students to get to school. How many students take 15 minutes to get to school. So we don't actually have to figure out all of these, right? Or even a range. We don't have to figure out how many students total were surveyed or told us how long it takes them to get to school. Some of these seem like it's kind of a long time, right? But again, if it were to ask, hey, how many students take 45 minutes to get to school? 1, 2, 3, you're just counting. So again, if you're going to struggle with the counting, maybe watching some Sesame Street is in order. I don't know. It's up to you. But you could make bars out of these as well. But I'm not going to yet. What I would like to see is just how many students take 15 minutes to get to school. Well, 15 minutes, that's this one right here, and it would create a bar this high. Now again, you just have to count how many dots that is. 1, 2, 3, 4, 5. So there's 5 dots, meaning that 5 students take 15 minutes to get to school. So again, a dot plot is similar to a histogram. And so if you wanted to, you could have said, well, that's a bar right there, and here's another bar right here, and another bar, and one that's 0 is fine, but 4 and 3 and 3 and 3, something like this. So again, it's just a different way to show a histogram, but we have dots instead of a frequency axis. The second part of the objective is to help us to figure out how data is distributed. Now, when we do it this way, whether it's symmetric or skewed, what we're doing is we are comparing the mean to the median, specifically the mean to the median. Okay, so if I were to look at something that was symmetric, like this histogram up here in orange, what I can do is I can kind of draw a line to get an idea of what I'm looking at here. So to get something that looks something like this. And yeah, it's not great, but it's not too bad for me. What we notice is that the peak of the line that I just drew, again, you wouldn't even have to really draw the line like I just did. But what we should notice is that it's pretty much cut directly in half, okay? So if we cut some kind of chart in half, then it's considered symmetric. And the reason why it's symmetric is because the left side and the right side are pretty much matches of each other. Now, is that an exact match? It is not, but it doesn't have to be in order to be considered symmetric. It needs to be just pretty close to symmetric. Same with this bar graph right here. Again, I couldn't say that this part of the box is the same as this part of the box. I mean, they look the same. I just can't guarantee that they are. And then the whiskers are the same length as well. Even from the median to the minimum, the median to the maximum, it just looks like it's cut in half pretty well right through the median. So what happens on these with symmetric is that wherever the median is, oh, if I can spell this, median is pretty much the same as the mean. Okay, maybe I should have put that in a different order. Like the mean is the same as the median. Doesn't matter. But if we were to look at the histogram, for example, you would have a median or about where that purple line is, but also that would be where the mean is as well. And the same thing is true for the box plot too. Again, that purple line would not just be your median, which we know that's the median because it's a box plot, but it would also be your mean. Or they'd be about the same. So the mean is the same as the median. Next up, for skewedness, you've got negative or left skewed. They're going to use either left or right on the assignment, but we would say, again, we're comparing the mean to the median. So you start with the mean, compare it with the median. So the mean on something like this one, where would it be? Well, it may be even easier just to figure out where the median is. But with the shape of this information, I'm looking at something like this. Now, is that exact? No, it is not. I don't care. But what I notice is that my median is going to be somewhere over in this direction. Notice that we're not actually asking you to figure out what the exact median is, although doing it with a box plot is pretty easy. But if that is my median, then the mean would be somewhere, again, just towards the middle. Middle in terms of location, not in terms of data. So that is where the mean is. The mean is to the left of the median. Mean is to the left of the median, which makes it less than the mean. It's less to the left. Mean to the left means it's left skewed. Or in this box plot, like I said, this one maybe you could find the exact value, but I know that this line represents the median. Now again, since I see that the median is there, the mean should be pretty much right in the middle. And I may have miscalculated that. It doesn't really matter, but I know that the mean should be somewhere here. And when I'm saying the middle, I'm talking about the middle of between the minimum and maximum right there. Okay. So again, the mean here is to the left of the median, even on the box plot. If it's considered right skewed, then the mean is to the right or greater than the median. So if we were to look at this histogram here at the bottom, you would get some kind of line. See if I can do this decently. It looks like this. That wasn't too bad for me. So with that line, now we know, once again, the center of the data, or the middle number of the data, would be somewhere over here. About right there, maybe. Which, again, we're not asking you to calculate that. We just need to be able to estimate about where it would be. But it should be about where the peak is, almost where the peak is of that line that I drew. And then again, the mean is usually always somewhere in the middle. Or pretty close to the middle, left and right of that line. Again, is that exactly the mean? No, it isn't. But it should be pretty close to there. Whatever the case, I do see that the mean is definitely to the right of the median, which means that my mean is greater than the median. And that would be true for this box plot. Okay, so I'm going to identify the mean on this one. So about right here, I'll call that my mean. It's the middle from left to right. And the median I see is to the left. So again, the mean is to the right. The mean is greater. Mean is greater than the median. The good news is, once we have this information down, and we may not have it down yet, we may need to refer back to this in order to answer the next few questions. But I'm just comparing the shape, and then if I can see just the general shape, then I can declare it either right or left skewed. You'll notice as well that it's not like they've made this come down like this, and then suddenly there's a big bar over here. That would complicate things, which we're not planning to do right now, since this is kind of an introductory to this type of statistics stuff. All right, determine the shape of this data set. Well, for me, I would say that this is the shape. It kind of looks like it's symmetric, but it kind of comes up and then back down like this one right here. Okay, so again, if I were to look for the median, first of all, I would expect it to be probably in this area, something like this. There's my median. Now again, from left to right, I would expect the middle of this to be somewhere over here, and that's where my mean would be. So, on the assignment, it's going to say, is it left or right skewed, or is it symmetric? Well, what I notice from that right there is that the mean is to the right of the median. So the mean is further to the right of the median. And that makes this the mean is to the right, which means it would be right skewed. Determine the shape of this data set. And again, we're not asking you to actually figure these out. They did give us a histogram with some numbers here at the top. That's all right. Looks pretty good. In fact, this one, again, is it exactly? It's not, but I'm going to say it's something like this one right here. So for me, Maybe you would think, maybe you could think that this one is right skewed, but again, the median, which I would expect to be about right here, the median is pretty much, again, right in the middle as well, where I would expect the mean to be. So since the mean and the median are pretty much in the same location, we would consider this one symmetric. And that's it. Now we have a box plot. So the box plot tells us directly where the median is. It's got to be this line right here. The median. Now, for my median, I have a minimum over here. And this is more to help us to kind of estimate where the mean would be. And then I've got a maximum way over here. So for me, the mean should be somewhere towards the middle. I don't know, maybe even right here. Now, is that exactly the mean? I don't know. I also don't care. What I know is that this mean that I just found is further to the right of the median, which means that this one should be right skewed because the mean is to the right of the median. Right also being positive skewed. If you need to refer back to that slide, which shows this type of box plot being right skewed, then do it. There we go. Determine the shape of this shape, the shape of this data. That's better. So I would expect it to be something like this. Now again, is my line perfect? It is not, but it kind of emphasizes what's happening here with the data set. So for me, I would put the median, I don't know, in this range right here. Now again, is that exactly the median? I don't think it is median, but it should be somewhere in that area. And then of course the mean should be somewhere more towards the middle. Again, whether it's right there or right here doesn't matter. It should be in this, around this area, which means it's to the left of the median. Since it's to the left of the median, it would be left skewed. That's it. Okay, location of the mean and the median will tell you if it's left or right skewed. This one definitely is not symmetric though, because it would have to be high in the middle and then low on both ends. All right, for this one we see IQR again, which is interquartile range. I don't think we're going to be using the interquartile range. I mean, you can still compare it, but for the most part, we're just looking at the range, or really it's going to be considered the spread of the data. So if the spread or the range of the data is narrow, so if you have a minimum here, you got a maximum there. Okay, now whether that's wide or narrow, we can't really say for sure. But if I were to compare it to another set of data with a minimum over here and a maximum way over here, of course, this, and again, this could be a box plot, it could be a dot plot, it could be a histogram, doesn't matter. If I see that the width is this wide and then this one width is this wide, but we're using the same number line to compare, then I can see this one's definitely wider. Wider is greater than it. Bigger, smaller, okay? So whatever's happening in between this, I don't really care about. I just need to find a minimum and a maximum to compare my spread or the range here. Now, if by chance, what they can do is they can say, let's take this set of data and it won't be right here, but what they'll do is they'll move it over here like this, and they'll say, now how's the spread? Well, they're the same spread, even though they've been moved, maybe one to the left, one to the right, doesn't matter, but it's the same width. And if they are the same width, then we can say they are the same width. On the other hand, if the center, specifically the median, which we're going to be comparing, if it's left, then it's less than, because further to the left on a number line makes the value less. Further to the right on a number line makes it greater. And then if they're the same, of course, then they are the same. So what they're going to do at the bottom here, they're going to have a number line for you. And then they'd say, here, compare this minimum to this minimum. Well, I can tell that this minimum is further to the left, this one's further to the right, this one's bigger than this one. However they want you to compare them, they'll tell you. We probably won't see any that are the same. That's minimums. Of course, if it was some kind of median, maybe a median is right here for this one. And maybe for this one down here, maybe the median is just a little bit further to the left. And that can happen too. But again, we would compare them to this number line down here. And this median being further to the right than this one makes it greater than. So while that probably is clear as mud, let's get on to this problem here. We're looking at these two data sets. I've got set Y on the top, and then I've got set Z below. We're always comparing on all three parts of this set Y to set Z. So I've got to figure out where set Y is and then compare where I would expect it to be for set Z. We're not actually asking you guys to solve these for either a median or finding the actual spread, although you could. The minimum is going to be easy to find just because it's the dot, in this case, furthest to the left, and that's okay. I'm going to start with the median because that's the first question here. The median for set Y, I would expect it to be somewhere in this area. Okay, so that's where I'm expecting the median. Now, is that exactly where the median is? I don't know, but I also don't care. Because the median or middle value for set Z has to be somewhere in this area. Now again, is that exact? It is not. But it should be pretty close to where it actually is. Maybe it's not even close. Maybe it's just somewhere in this area. I know now that if I were to compare this median to this one over here, set Y is further to the right than set Z, which would make set Y's median greater than the median for set Z. Next up, what we want is the spread. So if I am comparing spread of data Y, data set Y, I have a minimum here at 20, and then it spreads all the way to 33. Now you can actually make this line like this and compare the two. So if I were to compare set Z, it has a minimum over here and then a maximum over here. Just if I were to make two lines, you could just compare the lengths of the lines this way if you'd like. But either way, I can see that this one is much wider than this one. Set Y is more narrow than set Z. So set Y's data spread is less than the data spread of set Z. And again, we're just looking at width of those two. I don't care that this one, I don't care that they're symmetric. I don't care about any of that stuff. All I care about is the width of the data. And then last question is the minimum, which I can't find. It was the leftmost point here for either of these. So for set Z was 13. For set Y, it's 20. Now again, it's comparing set Y with set Z. So set Y is compared to set Z, well, it's to the right for its minimum, which makes it greater than. The minimum of set Y is greater than the minimum of set Z. Done. Now we got these box plots, and that's okay. Once again, we're just comparing spread, center, and minimum. Let's start with the median. The median, which is clearly outlined in a box plot like this. So this is my median right there, 25 for data set F. And I can find the median for data set G right here. Now you can compare these on the same number line, just kind of follow this up, and that's your median. But at least for these two, I see that data set F median is to the left of data set G median. Since it's to the left on the number line, that makes it less than the median for data set G. Next up, we want the spread, which will include the minimum. We see this one's 19. And then this one, even though it's one to the left, it is one to the left for our minimums. So we could compare the minimums right now. And I see that data set F has a minimum to the right of data set G, which makes its minimum greater than the minimum of data set G. So now that we have that, well, we compare that with the spread of data set F, which goes this wide. And again, I don't really care about the numbers because I can see that the width of data set G. There's my minimum. Once again, if I were to compare these as lines, I'd have this line for data set G and this more narrow line for data set F. And since data set F's line is less wide or more narrow, either way, its spread must be less than the spread of data set G. That is all for this one. So based on the data set, complete the following sentences. Again, we'll compare the median. Now, do I know exactly where the median is for these? I don't. And perhaps you do, or maybe you'd be willing to actually figure out what that is. But for data set N, I'm expecting the median to be here. Now again, is that exact? Probably not. Maybe one to the left, maybe one to the right, I don't know. But I can see data set O, its middle value should be about right there. Okay, so comparing these two, they have the same number lines, which is good. But I can see this one is just a little bit further to the left than this one right here. Set O is further, set N is further to the left than set O, median. So where I'm comparing the medians, set N's median is to the left, which makes it less than the median of data set O. Likewise, we can find the spread, so I've got a minimum here in set O at 40, and over here I've got a minimum of 42. On the other hand, we have a maximum for set N at 54, and a maximum here at 59 for set O. Now, you don't actually have to figure out the full spread, right? The subtraction, it's not that hard, but you don't necessarily have to do it. What I notice is that the width of the data, again, just a straight linear width across left and right, set O's is a little bit wider than the spread of set N. So right here it says the spread of data set N, it's thinner or more narrow, which means that its spread is going to be less than the spread of data set O. Now the minimums, which we've already found, even though they're pretty much right next to each other. This one, on data set N, we have a minimum of 40. On data set O, it's 42. 40 is definitely less than 42, so for the minimum of data set N is going to be less than the minimum of data set O. And that's it. That's all we got to do for this one. If you guys are feeling pretty good about that stuff, here's our objective. I can interpret and compare dot plots, box plots, and histograms. And then we also went, the second part of the objective, what's the skew of the data, left, right, or symmetric?